I should be recording this. So everybody got number 1. And now with number 2, we've already laid out all this work. We've got our forces labeled. We've done a sum of forces on the x-axis. And now we're looking, we want to know how far up the slope this thing goes. So the work overall is equal to the net force times distance times cosine of theta. And that theta is going to be, for us, the way we've been doing these, either theta of 0 or cosine of 0 or cosine of 180. Which will it be here? So which direction is the force on the object? This way. It's 180, because the motion we're interested in is this motion. Now, the sled's going to come back down, but we don't care about that part of its travel. We're concerned with how far it gets. So that's going to be cosine of 180. And I'm going to just put that in there now so I don't screw something else up. Well, we also know that the work on the object is equal to 1/2 mvf squared minus 1/2 mvi squared. And we know that we're looking for the point at which it stops. So we're looking for the point at which that zeroes out and disappears. How many of you had this up to here? Okay.
I just messed up my sum of forces.
Yeah, I did.
Okay.
I accidentally left one of them positive instead of subtracting.
Oh, so you had a difference between them rather than the sum of their magnitudes.
Right.
Okay. So now what I've got is F net times D times cosine of 180 is equal to negative 1/2 mvi squared. And I'm solving, of course, for distance. So distance equals mvi squared over 2 F net cosine of 180. Now, to get F net, of course, we have to dig into the mu k. So mu k is equal to Fk over Fn, which means that mu k Fn equals Fk. Well, that's great. That gets me part of it. Of course, I don't know what Fn is. So I have to do a sum of forces on the y, just when you thought it was safe to go back in the water. And I know. And that's equal to normal force minus F of g y. So Fn equals Fgy, which means Fn equals mass, gravity, cosine. And I'm going to be careful and put in my slope here so I don't screw this up. And it's a 25-degree incline, so cosine of 25. Okay, so now I can sub in that for Fn, and I now know that Fk equals mu k mg cosine 25. So far, so good? Let me move that up a little bit so it's not obscured. Okay. Okay, to tie together our F net, coming from here. F net equals negative mu k mg cosine 25 minus, well, of course, f of gx is going to be mg sine 25. If you want to simplify life for yourself a little bit, you can factor out mg. I actually think that makes it easier. So you have mg times quantity negative mu k cosine 25 minus sine 25, less math to screw up. If we take this whole bloody mess and plug it in for the F net there, what we end up looking at is, so D equals mvi squared over 2 times the quantity mg times the quantity negative mu k cosine 25 minus sine 25. Raw answer is 1.3504, blah, blah, blah. Yeah, and it sig figs out to 1.4. So 1.35042. Where were your mistakes? Okay.
I had a force applied in my sum of forces.
Okay. So that's, yeah, that's a good one, is, you know, making sure that you don't have an extra force, making sure you've represented all the forces that were there, making sure that you understand what direction the forces are in so that you know if it's the sum of their magnitudes or the difference.
I just got confused with, like, the whole, like...
There, I forgot the cosine of 180. What that does is it gets you a positive distance. Because your forces are all negative, you're multiplying the whole thing by -1. So then that gets you a number for distance that's positive because it's going upslope before it slides back down. So.
I just wasn't sure what I did because I still like my forces, like my F-net, like I still.
Apparently I also dropped my negative. Now wait, what does that do to me? Yeah, then I would have to call my forces positive. Huh. Well, that's a bummer.
I didn't really.
Oh, wait. No.
I didn't leave all that algebra in. I like did subsections.
Okay.
I like found the like force of kinetic
Okay.
energy first.
And I think that's
and then
totally
I just
reasonable.
Did the work equals FD cosine theta and just rearranged. So I had like.
I think that's completely reasonable.
W over F cosine theta.
Yeah, I'm troubled though by the inconsistency here. I don't know how to rectify that just yet.
I don't really know what you did.
Okay, so we can also do sum of forces on the y, where Fn minus f of gy is 0, so Fn equals mass gravity cosine theta, and we take the mu k, which is equal to Fk over Fn, so mu k Fn equals Fk, which means mu k mg cosine 19 equals Fk. Yeah, you can do either of them. Let me now shrink all that. So the work done by kinetic friction is equal to either force applied minus mg sine theta, or sine of 19, or mu k mg cosine 19 times distance times cosine of theta. So which way is the thing moving? Up the ramp. Which way is force kinetic friction? Down the ramp. So they're in opposition. So that's going to be times cosine 180. Okay, so for the work done by kinetic friction, we get a raw answer of negative 280.87 blah blah blah, and it sig figs work done by kinetic friction negative 280 joules. Okay, that's part A. I think most people did pretty well on part A. Part A was pretty easy. Part B was a little harder. And then, oh yeah, you know what? Mu K is much easier. Hey, I'll just do the mu K. I'll do the sum of forces on the Y route. And I realized I had to do the sum of forces on the X anyway for part B. You can't solve part B without doing the sum of forces. So part B asks for the final velocity of the block. So for that, you have to do the fact that net work is equal to change delta KE. And in that case, we know that the net work equals Fnet d cosine theta, and this thing's going up, so that's going to be theta 0. I saw the gum spit it out. So there's that, and then net work also equals 1/2 mvf squared minus 1/2 mvi squared. We know that the initial velocity was 0, so that goes away. I love it when we can get rid of things. So we now are down to Fnet d, because we got rid of cosine theta, equals 1/2 mvf squared. And we can proceed to solve for vf. The algebraic solution is not terrible, but there are some substitutions. So I've got Vf equals the square root of 2 Fnet d over m. We got rid of the cosine theta here. We got rid of the 1/2 mvi squared there. Pretty simple, but now we just need our Fnet. And of course, that is this, the force applied minus the force of kinetic friction minus the force of gravity on the x. So you plug all that in, 726 It turns out you pretty much need every bit of everything else that you did anyplace else. So you can't really save yourself any work on that. You get a VF raw answer of 14.93 blah 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 meters per second. VF final is 15 meters per second. Okay, that's it for these. How many of you are totally done with the homework up to 5C?
I think I'm on number 5 on that.
Okay. Okay.